Welcome to a new video tutorial for the lighting application suite, the LUS. This now is video number 12, and what is different this time compared to the other videos is that now we are in the lighting application suite version 7.0. And one of the main features of this version is the possibility to manage and control DALI devices. There are many other features in this version of the LUS. Have a look at the manual to see all the other new features and functions. So now we have a DALI integration in the programmer with the Ethernet to DALI interface and engine. We'll see some facts and figures of DALI, how to integrate the Ethernet to DALI, how to set up our DALI environment, and how to control DALI devices. We will only talk about ballasts in this video. There will be a second video about DALI and about input devices like keys and sensors and motion detectors. So here a general overview. For details, please download the system manual of the LUS 7.0 available from our website. First, some info about the Ethernet to DALI and about DALI in case this is new for you. The Ethernet to DALI can either be an interface for the lighting application suite, or it can run as a standalone engine without a LUS server. In this case, it is an interface and it has two DALI lines, it has one DMX universe, and it has digital dry inputs. Connected to the Ethernet to DALI are ballasts with a DALI interface. And these ballasts control various types of fixtures and lamps. There are ballasts available for every type, every kind of fixtures today. You can also connect standard switches as input devices over so-called key couplers, or you can connect sensors like motion detectors and light sensors over a so-called sensor coupler. The topology of DALI is quite simple. It's just a two-wire system, and you can connect all devices over this two-wire system, and you can build every possible topology. It's really independent from any structure. Two expressions you should know is the grouping. You can put together ballasts in groups, and you can then control these ballasts in one group with a single command. So putting together the three ballasts in a group means you can send one command to control the ballasts. And another expression is the broadcast. Well, easy to say, every connected ballast gets addressed. A maximum of 64 devices per line is possible, and you can have in one line a maximum of 16 groups. So a ballast is the device which controls the luminaire, and it is intelligent. It has internal functions. One of the many data stored in a ballast is the so-called short address, which is used to address the ballast, and there's another internal address which is called the random address. This can't be changed, this is fixed. There are a lot more values stored internally. One is of course the set of groups where this ballast belongs to, and you can have the minimum and maximum value. This is the maximum and minimum intensity the luminaire can be set to. There are also two other values. One is called the fade rate and one is called the fade time, and they are used for the dimming and switching speed of the ballast. Also internal values are the scenes. Scenes are kind of presets, pre-stored, predefined intensity values, which can be stored and recalled. More information and more details can be found in the LUS manuals. They are available from our EQ site or from our Traxon site, and one additional source of information is in the DALI group, which has a so-called news and service section. There's a DALI manual which shows all details about DALI you can and sometimes should know. So the configuration we are using here is quite simple. It's a one Ethernet to DALI and a single ballast, which speeds up the whole operation a lot. There's also one key coupler with some switches there, but we will show and we will discuss input devices in the second DALI video. We'll start from scratch here. My Ethernet to DALI is connected to the LUT server running the programmer. It is not used in the device manager, and first thing I would check is that it has a valid IP address. I can see the IP address here in the network tab in the programmer. If I want to change it, I click on the Ethernet to DALI and I could now change the IP address here. Make sure that it is not a 1 in the end, because 1 is the factory state. Replace this one with a valid and unique value as an IP address. Now the data is written back to the Ethernet to DALI. I now open the device manager and start a system scan, and it will find 3 devices, one for DALI, one for DMX and one for the terminal connectors. One important thing to know is that unlike in the DMX world, phantom setups without any real devices are possible, but they are really virtual. You can't really test the configuration. DALI is a master-slave protocol with a constant data exchange. Sensors are only visible when online. Here, DMX and DALI are different. Now I can configure, for example, the DMX output of the Ethernet to DALI, and the only thing I can define is the output universe. Well, we leave it like this because we don't use it here. In the terminal section, I can again give it a proper name, and I can also control the state of the relay outputs when the device comes up. In the settings, you can define for the digital inputs actions. For example, start queue list number 1. So if this input of the Ethernet to DALI is set to 1, then the queue list number 1 will be started. The configuration of the DALI section is quite simple. You can set a name for it. Usually you can leave the name like it is. It must be unique, otherwise you can't address it. And if you want to use the action pad or the mobile action pad with the Ethernet to DALI in standalone mode, don't forget to check this action pad. Another new thing with the Ethernet to DALI are the labeled events. Labeled events can be used in standalone mode. You can send a string, and on this string you can then define an action. For example, a labeled event like start QL1, and I can now, with sending these strings to the Ethernet to DALI, a queue list. This is a new feature in the LUT 7.0. So the Ethernet to DALI is completely configured. I can now close the device manager. Configuration of the DALI subsystem is made with the DALI manager. This is available from the top menu. I click on DALI manager and a window opens. The first thing you usually do when setting up your configuration after connecting your ballasts, etc., is to assign short addresses to all connected devices. And you do this the first time when you set up your configuration, and you always have to do this again if you replace ballasts or if you change the configuration. So first I will assign short addresses. I select line A of the Ethernet to DALI and click on address ballasts. It will now scan the system, and here you can see the random addresses, and now it has found a single ballast with this random address, and it will then assign a short address. In this dialog you can also select if you want to use the properties from your show, or if you want the properties which are already stored in the ballast. Here I use from show to use the configuration from the programmer. If I now click on assign new addresses, it will assign short addresses to all connected devices. And this is one reason why I have only one ballast here. If you have, for example, the full number of 64 ballasts, it will take longer than with a single ballast. Now I have my ballast available here. You can see it displays a status lamp error, and that's correct. The ballast has no connected lamp, and this gives an error message because the ballast detects that the lamp is not present. I can now configure my ballast clicking on the ballast. I can give it an alias name, the short address is 0, or the gray fields are non-editable, they are read-only. And you can also see that the status and the currently get updated in a circular mode. I can set the power on level, I can set the minimum value for the intensity or the maximum value for the intensity. If I click in a field, for example here, I want to change the minimum level to 10%. If I leave the field, you can see a short icon here that the value in the ballast is changed. You can also define the fade rate and the fade time for the ballast. The fade rate is used in step and ramp functions, and the fade time is used when setting intensity directly. If you click on this field to set a fade time, you will see rather strange values. Not 1, 2, 3, 4, 5, but the values in the ballast are stored in binary and are then remapped to decimal values, and this is the reason why some values seem rather cryptic. So I can also assign this ballast to a group, and some other values are available here, for example serial numbers, firmware version, and I have the scenes in the ballast. You can now see that some values are already defined, and a -1 means there's no defined value. This way I can set all the properties of my ballast. I have also another view for the groups here. I can set properties for ballasts that belong to a certain group. I can also send here a minimum value, a maximum value, a fade time, fade rate. And there is no ramp function at the moment running in the group or in the ballast. There are a lot of context menus behind the leaves in this tree. A context menu shows if you go to a leaf and click the right mouse button. If I click it on ballast, I can show all ballasts, I can show only addressed ballasts, I can scan for ballasts, I can remove short addresses, and I can use the indicate functions. The indicate function switches the intensity value of the ballast from minimum to maximum level to check your configuration and see what ballast is addressed here. So this is the DALI manager. The DALI system is configured. I have my ballast. I have also my inputs here, but about inputs we will talk in the second video. Now the configuration of my DALI subsystem is complete. I will close the DALI manager, and the next question is how to control DALI ballasts, and this is done the same way as usual in the programmer with triggers and actions. Triggers and actions were shown in detail in video number 7 of this series. So to define a trigger and an action, I click on the top icon and I can now define a new trigger. The trigger rule dialog in version 7 of the LAS looks a little bit different than before,
because there's an additional tab which is called condition. I will come to that later. So first of all, I will select a trigger, and in this case, let's take a sunrise timer as a trigger on Monday to Friday, and at twilight AM this trigger will be raised. The next tab is condition. The condition tab is new in last version 7, and you can limit the execution of an action to certain conditions like date, time and astronomical events, even the state of devices in the programmer. We don't need a condition here, we leave it like that, and will now define an action to this trigger. And there is a new action in this version of the programmer. It is the DALI action. I have to select the device, I have to select the line, I have to select the address type. This can be a single ballast or a group, or you can do a broadcast. I can select the ballast or the group, and I can select a command. There are lots of available commands. You can set a predefined intensity, you can do a ramp function, ramp up, ramp down, you can do step intensity, you can recall a scene, or you can store a scene, or you can toggle intensity between off and the last on value. Here I will select only intensity to set an intensity. The value source is not used here, and I want to set the ballast to an intensity of 50%. The fade time will be used from the ballast setting, and you see again here the value is recalculated to 49.2%, and this is due to the remapping of binary values and decimal values. All the possible commands that are listed here are discussed in detail in this system manual of the LAS, so I will not go into detail here, otherwise this video would last an hour or more. Now I've defined an action for this trigger, so the trigger is twilight AM, and the executed action, ballast number 1, is set to an intensity of nearly 50%. So this is now the defined trigger. You can even do more with the action pad. I open the action pad, I'm in edit mode. I will now add a generic button. Double clicking on the button opens the properties dialog, and I can now have two actions. For example, in the first action I could select DALI, and this time I use an address type group. The group number 1, the command is intensity, and I want to set these group of ballasts to 50%. And as a second action, I use DALI, the Ethernet to DALI, the group, and the group number 2 would be set to an intensity of 10%. So now with this single button I can set one group of ballasts to a value and a second group to another value, for example in a restaurant or wherever you need to control with one click, one button, several groups of ballasts. So altogether, the configuration and definition of your DALI subsystem is done with the DALI manager. You can define parameters, you can define groups for ballasts,
And control is done either with a trigger and a connected action, or for example via the action pad. So this is an overview over the DALI capabilities of the Lighting Application Suite 7.0. The best way to get familiar with the DALI subsystems and all the functions that are available, and there are many functions in the DALI Manager, in the automation, in the action pad to control DALI, because it is fully integrated, is to play around and to check what the various parameters do. The system manual lists all the parameters, and there's also a description what the parameters mean, what they do, but really the best way is, well, just play around a little bit and make your own experiments. So this was the DALI section of ballasts 7.0 for ballasts, and the next video for input devices like motion detectors, light sensors and input keys, well, will be available soon.